it. Am I audible? What is the structure of BDS?
One or more records for subject for analysis reports. Parameters, sir.
What is the structure of BDS? One or more records per subject per analysis parameter per analysis time point. But you do not require analysis time point every time. If you do not require analysis time point, then what is the structure? One or more records per subject per analysis parameter. And what are the variables that we are going to have? We are going to have a demographic variables. Sorry, we have a identifier variables. We have a treatment variables. Then we have a timing variables. Then we have a param variables. Then we have a base variables. Then we have a change variables. Then we have a toxicity grade variables. Now, reading and understanding all the variables would be difficult in the real time, but I told you at least read it 4 or 5 times so that you get some familiarity. Now, in today's class, I will tell you how to create a BDS dataset. And I told you generally from where we create these BDS datasets, we always create these BDS datasets from SGDM findings datasets. Now, how to go from SGDM findings datasets into ADaM BDS dataset? Now we'll take a simple example and I will try to understand so that if you could able to understand today's topic, you will get an overall idea how to create a BDS dataset. Okay. Now, what is the major difference between ADaMs and SGDM? ADaM datasets and variables are going to have more and more redundancy for easy analysis. We are going to have the same common variables in all across all the analysis datasets. Like we are going to have a population flags, we are going to have subject identifiers, we are going to have timing variables, treatment variables. We can find the same variables in multiple datasets. Now, the major important difference between ADaM and SGDM is in ADaM, so more and more variables are going to be numerical variables. In SGDM, you might have seen the DM domain. Do you know how many numerical variables that we have in the DM domain? Any idea? How many numerical variables out of 28?
2.
Only 2 variables. One is age and another one is DMDY. Isn't it? So in SGDM, we are going to have very few numerical variables. In ADaMs, we are going to have more and more numerical variables because in future, I'm going to use ADaM for analysis purpose. So if you want to use it for analysis purpose, it should contain a numerical data as a numerical data. And ADaM datasets may combine variables from multiple SGDM datasets. Say we know that ADSL. From where we create ADSL, we create from the DM, subject characteristics, exposure, vital signs, disposition. In the same way, I'm going to create in future ADLB. I'm going to create ADLB from ADSL plus LB domain. And already you know that what you mean by ADSL. ADSL is a combination of 5 domains. So 5 plus 1, 6 domains for ADLB. And you know that all the ADaM datasets starts with AD. So in ADaM, the dataset name is going to be 4-letter. ADSL, ADLB, ADVS, like that one. AD stands for analysis dataset. Now, How to create a ADaM compliant basic data structure? The first one is a BDS dataset contains one or more records per subject per analysis time point per analysis parameter for analysis time point. That's the structure. It describes the data being analyzed and also includes variables to support the analysis. And I told you we are going to have two types of variables, two types of observations: analysis enabling and supporting. So we are going to have both type of variables. And then next, now from now onwards, the total process of creating a BDS dataset from SGDM dataset we can divide into 6 steps. The first step is we should create a source dataset, we call it as a precursor dataset. The second step is we need to convert all the character dates into numerical dates. And the third step is, we should create a dy variable. And the fourth one is, we have to create all the important analysis variables like PARAM, base, and we should create all. If you require any time point windows, we should create those time windows. And finally, we are going to create, the change variable. So we can divide the total process into 6 steps. Now we'll see what are the 6 important steps that we have, how to go with that. How to create the first one, which is in a precursor dataset. Now, if you want to say, for example, take ADLB. So from where we create this ADLB, we create this ADLB from LB dataset of SGDM. But sometimes, whatever the extra information that we couldn't able to keep in the LB, remember where we kept that information? ఏదైనా ఒక ఎల్బి డేటాలో డేటా ఉంచలేకపోయినా అనుకోండి, అకార్డింగ్ టు SGDM IC guidelines, where we put that information, remember? In the sub LB. We create a supplementary data set, we'll put that information in the supplementary data set. Now, I want to have the supplementary information. Sometimes I may require to create ADaM dataset. But you know that how we created the supplementary, remember? We created the supplementary in vertical manner. So that's why what we did, we transposed that variables and then we created the supplementary LB. Now, what I'm going to do, I'm going to combine my LB dataset with the supplementary LB. By combining both, I'm going to create a source dataset. But if you want to do in that way, but LB is in a horizontal structure, but supplementary LB in a vertical structure. Again, what should I do? Whatever the supplementary LB that we have to retranspose it back, and then we should merge that dataset with our LB dataset so that we can create LB plus supplementary LB. We can create a source, a precursor dataset. Very, very important interview question. And they will ask you, some of the variables that may require for ADaM datasets may be present in the supplementary dataset. How we are going to get those datasets, those variables back? Tell me what we should do. We should transpose that supplementary dataset and then merge with main dataset. So how we can transpose? Tell me the syntax. That is the question that you will get it. Remember, what are the variables that we have in supplementary dataset? Any supplementary dataset in SGDM? We have study ID, use subject ID, domain, ID var, QNAM, QLabel, QVal, QAVAL, QHorizon. Now, when you're transposing it back, how we are going to do the syntax? Our main goal is I want to get the vertical values into horizontal. Which variable you should transpose in the supplement dataset? You should always transpose QVal value, QVal variable, because QVal contains the values, and I should get again that back into a horizontal manner. So QVal is going to be in the var statement. By which values you will do it? I will do it by study ID, use subject ID. And remember what we have in ID var and ID var well?
Don't know.
ID var well, sequence number. Very good. We are going to have a sequence number. Now, by keeping those 3 variables in the by statement, I will transpose it back. Okay. Now, see, I'm giving an example. Either here on the top table, this is an LB data set. We have a U subject ID, we have a 6 LB sequence, LB test CD, and LB ORRS. Sequence number is 1, test CD is sodium, and ORRS value is 1. So here I have supplementary data set. The supplementary data set is going to have a study ID, R domain, U subject ID, ID where well, Q norm, Q val. We don't require other variables for example purpose. Now, here we have in a vertical manner, we should get that into horizontal. Now, what is the common variable by which we can understand, we can relate a supplement data set with the main data set? Identifying variable. What is the identifying variable? Sequence. Okay, now I want to get this back. Now, how I want to get this now? Whatever that LB fast value of which variable? Q norm. So this LB fast, I want to have it as a variable name. And whatever the QVal value that we have, I want to have a value in the transpose data set. So LB fast should be the variable name in the transpose data set, and this must be value. So I'm going to LB fast in ID variable and this QVal in the by statement. So I will write by U subject ID sequence, U subject ID, study ID, U subject and sequence. Then I will merge both the data sets after the transposition. Now this is the final data set I will get. Now I am going to take this one as my source data set. Okay. Now this is the program that we are going to proc transpose. Data is equal to supplementary LB, out is equal to sub LB2, and by U subject ID and ID, study ID, U subject ID and ID where well, and where Q well. Very important. ID is a Q num, and ID label is equal to Q label run. So very, very important interview question. Then now the vertical is going to become horizontal. Then I will merge this sub LB2 with my LB domain so that I will get it. Whatever the value that you submitted in the transposed in a supplementary LB, we'll get it back into main data set. Now we are going to create a source data set in that way. This syntax is very, very important. You are going to get a question from this one. Okay. And the next. The second step, convert all the dates, character dates into numerical in ISO 8601 date. Whatever that ISO 8601 dates that we have in SGDM, we should convert that into numerical. Now, we have a variable called LBDTC in LB domain. You know that it is nothing but a sample data collection date. From this LBDTC, now we should create 3 new variables. Date numerical is going to be ADT, analysis date. Time numerical is going to be ATM, analysis time. Date and time numerical is going to be analysis date and time. Tell me what is the SAS program that you will write to get the date numerical from this one, time numerical, date and time numerical. How will you get that one? Anybody?
Using input function.
By using any, if you want to use the date part and time part, the data should be in numerical. Is this data in numerical?
No, sir.
No. We have a character data. Always the SGDM data is going to be character data. Then what we should do?
First convert that into numerical and then
How to convert that into numerical?
Input.
By using input function, now we can get only date part, time part, and if you want to get the date part, you can get the date. You can get the date part, date and time. If you want to get the time part, you should use a subbase function. We got only character time. Then we should, by using input function, we should convert that into numerical so that we can have analysis date, analysis time, analysis date and time. Okay. Then the next one is now. So this is LBDTC. Remember, just imagine this is LBDTC. LBDTC should have both date and time. Now LBDTC contains a time part. Time part kuda undanukondi, well and good. Now we can divide our programming concept into 2 parts. If you have a date, how we should proceed. If you have a time also, then how we should proceed. Now we'll see first of all the date part. Process the date part. Okay. Now, in the date part, I have a missing value. Date part lo ganaka missing value untai. Remember what I told you? If you have missing value, what we should do? We should create a flag. How to create a flag? How to create a flag? What is the flag variable that we have for date? DTF. The variable name is DTF. If you have a day missing, then what is the value will have?
D, sir.
Month miss aithe?
M, sir.
Year miss aithe?
Y.
Date anta complete ga unte?
N.
Blank space. No. Say for example, I do not have any incomplete, I have a complete date. Okay, and I have a year value, month value, and day value also. So there is no incomplete, everything is complete. Then simply convert that into numerical. Okay, but unfortunately I have incomplete. Yes, it is incomplete. First of all, you should create a flag, and the flag is going to have either D, M, or Y. If you have only missing date value, day value D, month value M. If you may have missing month and day also, we are going to have an M. If you have a missing year value Y, if you are missing everything, that is going to be Y. Okay, first we should create a imputation flag, and then later we should impute based on the sponsor's requirement. If the day is missing, he will ask you keep it as in the first day of that month. If it's a month also missing, take the first day of that year. According to that specification given, we are going to add the date values, incomplete dates, and then we are going to have a complete date. Then we are going to convert that into numerical. Understand? So if you have a date, the date can be two types. If you have a complete date, just simply directly convert into numerical. But if you have incomplete, create an imputation flag, then impute that one, whatever that you require according to the sponsor's requirement. Then after that, convert that into numerical. Understand this one? Now coming to the time part. If you have a complete time part is a complete. Yes, it is a complete. There is no missing value. They simply convert that into numerical, because we have hours, minutes, seconds, so that you can, by using input function time8 you can convert that into numerical elapsed number of seconds. But if you have a missing value, imputation, then create imputation flag, ATMF. If you have missing seconds, yes. Missing minutes, M. Missing minutes and seconds, M. If you are missing hours, H. Hours, minutes, H. Hours, minutes, seconds, H. But if you do not have any missing value, the imputation flag is going to be missing value. And based on the sponsor's specification, add that seconds, minutes, or hours value. Then after that, convert into numerical. Then we have a time numerical, date numerical. By using DHMS function or whatever the function, we are going to concatenate both. Now we are going to have analysis date and time. Understand this concept?
Sir, a missing value లేకపోతే DTF missing ఉంటుందా సార్?
DTF missing ఉంటుందండి.
ఓకే, అంటే
డేట్ లో మిస్సింగ్ లేకపోతే DTF లో మిస్సింగ్ వాల్యూ ఉందంటే we have a complete date. If you have a TMF లో మిస్సింగ్ ఉందంటే we have a complete hours, minutes, seconds.
ఓకే ఓకే సార్.
Understand everybody this one?
Yes, sir.
Okay. Then we'll go with the next step. Now this is what we do. Now can you see in this example, I have a date and time together. First, what we need to 2003 12:15 I should get into the ADT. 13 o'clock 14 minutes 17 seconds we should get into ATM, because we have a complete, not a problem. But in the second example, I have a missing seconds. If you are missing seconds, then what is the flag we should create? Time flag. And what we should have in that, yes. If the sponsor said add 00, we should add 00. Understand this one? And then coming over here I have complete date, but I have only hours. I do not have minutes and seconds. Then what should I do? We should create a time imputation flag. What we should have in that? Sorry.
Minutes.
Since we have a minutes and seconds also missing, we should have M. And according to the sponsor, he asked, please take that 00. So according to that, we need to concatenate. Here I have only date. So I have a complete time missing. So we can't help it. So we are going to keep it like that one. Now, I have year and month. There is no day value. Then what is the imputation flag will create now? Date imputation
Yes,
flag. In that we are going to have date.
ADTF.
So if here we have a 2003 December, now sponsor is asking take the first day of that month. I'm going to add first 01. Here I have missing value for both month and day. Then the imputation flag I'm going to have M.
month.
So I will take that the first day of that year. So it is going to be, it can be first day of the year, but again, the sponsor will tell you, I started the treatment and so on. So to take that first day of that July month, according to that, I'm going to add. Depends on the study and the sponsor. This is how we are going to create it. Next, the third important step, create analysis related date. If you already created an SGDM, you can get the same thing. Otherwise, we should create it now. Remember, we already created LBDY in LB dataset. Remember what was the algorithm that we have written for LBDY? What was the algorithm that we have written for LBDY? If LBDTC greater than equal to RFSDTC,
Then
then
LBDY is equal to
LBDTC minus RFSDTC plus 1.
plus 1.
Else, if LBDTC is less than RFSD, then LBDY is equal to LBDTC minus
RFSD.
Very good. Now we are going to say here also the same story. LBDT minus, I'm telling in general format, but if you want to do it, it should be in numerical format, no? So LBDT minus, where RF is nothing but what? Treatment start date. Okay, so this is how we are going to write that algorithm. The next one. Now, fourth important step, we should create important variables. We call it create key analysis variables. And I told you what are the key variables. The most important variable in a BDS is a param variable. This is SGDM LB domain. Now I'm creating an ADaM ADLB. I told you by concatenating LB test with LBSTRESU, what is the variable I'm creating now? Param. I have a test called sodium, and the standard units we have millimole per liter. By keeping the millimole per liter within the parentheses, by concatenating with the test, I'm creating a parameter. What is the parameter here? Sodium within the parentheses millimole per liter. And then second test is potassium, again millimole per liter. So by concatenating LB test with LBSTRESU, what we create? We create a param variable. Very, very important entry question. Then how we create a param CD? Param CD nothing but, what is this? LB test CD. And I told you, AVAL is always what? Which variable we are going to change that in LB? So these are the very important key variables, and we should create all the key variables. Understand? So the test CD of findings data set will become param CD. Test and STRESU will become param, and STRESN will become AVAL. Okay, these are very, very important variables. And then next, and another important, sorry. Now, in SGDM, I have two observations for same test sodium, and we conducted both the sodium. These are the tests I conducted on the same day. Can you see LBD? What is LBDY?
Day 1.
What do you mean by 1? What is the day 1 means?
Study day.
Day 1 is the study treatment start date. Isn't it? Whenever we started the treatment, that day is going to be study day 1. So we conducted the sodium test 2 times on the same day. When we conduct the first time, the sodium value is 139. When we conduct the same test for the second time, the value was 145. Now I told you which one you should take in a baseline value. Remember, I told you what is the baseline definition? The most recent value on or before the treatment. So we have on treatment start date, but we have 2 times. Which one I should take as a baseline? Now the sponsor strictly said, take the average of these 2. Now, with that average, I'm going to create a new observation. Can you see in ADLB we have a new observation? And this new observation, is it an observed value or derived value? You know what you mean by observed? Observed ante kanaka test conduct cheste vachina value and derive ante kanaka if you derive it from other observations.
Derived value.
It is a derived. This is not an actual test. We derived from the previous test. So I have 2 times 139, 1 time 145. The average of these two is 142. Remember, in ADaM's, we are going to create a new observations. Here we created a new observation. Very, very important. Now, since I created this observation, we are going to have a very important variable called D type. You know what you mean by D type? Derivation. How we derived? What is the algorithm that we use to derive this one? We use an algorithm called average or mean, because this is an average of the previous 2 observations. And now we have 3 observations. Which observation I am going to take it for analysis purpose? This average value. Why I created this average? To take it as for analysis purpose. So now we have 3 observations for 1 test. Which one I'm going to take it for analysis purpose? Now this observation I'm going to take it for analysis purpose. That is the reason I'm going to create a flag called analysis 01 FL is equal to Y. So in future, whenever I want to conduct doing the analysis for sodium test, I don't take these 2 observations. I will take only this observation value. By writing a condition ANL 01 FL is equal to Y, then I will take only that observation. Understand this one? Now, the next step, add time windows. Little bit tricky, try to understand it. You know, here I have an example study. The duration of the study is 180 days. So this is the baseline. This is a study day 1. And we have given up to the 90th day, we have given the treatment 1. From the 91st day to 180th day, I have given the treatment 2. Okay. I want to do analysis for the treatment 1. Which day I need to take to resemble or to represent the treatment 1? Now the response is telling, take day 45 to represent for whole treatment 1. అంటే ట్రీట్మెంట్ 1 లో అనాలిసిస్ ఎఫికసీ ఎలా ఉందో లేదా సేఫ్టీ ఎలా ఉందో చేసేయాలనుకోండి, నేను ఏం చేయాలి ఇప్పుడు? ట్రీట్మెంట్ 1 డ్యూరేషన్ ఇస్ 90 days. I should do day 1, day 2, day 3, day 4 like this one. So if I do that one, the result is not going to be so desirable. What I'm going to do, when the duration is 90 days, to understand that one, I am going to take the 45th day of the study to represent the treatment 1. If I do analysis on day 45, it is going to represent the whole treatment 1. So now what we are going to do, now I'm dividing my whole study into 3 windows. One is baseline. I'm considering minus 70th day to plus 7 day as a baseline. From 8th day to 90th day, I'm taking as a treatment 1 window. From 91st day to 180th day, I'm taking as a treatment 2 window. So now we have total 3 windows. To represent the baseline, I'm taking the day 1 to represent the baseline. To represent the treatment 1, I'm taking the 45th day. To represent the day 2, I'm taking 135th day. చూడండి, ఒక సామెత ఉంటుంది మనకి, అన్నం ఉడికింది లేదా టెస్ట్ చేయాలనుకోండి, డూ వీ నీడ్ టు చెక్ ఈచ్ అండ్ ఎవ్రీ గ్రెయిన్? No, right? 1 grain is enough, right, to check whether that boiled or not. So now I want to check treatment 1 how it is working. So what should I do? I don't need to go with each and every day. I will take 1 day. What is the date I'm taking this study? 45th day. For treatment 2, which day I'm taking now? So if I do analysis 1, it is going to represent from the 91st day to 180th day. So if you require any windows, treatment windows or time windows in our study based on the specification, now I'm going to create the windows. We'll see programming later how to create those windows. Now, the last step that we have is, derive change from the baseline. How to derive the change? Here we have a simple example. I have here a test called sodium. Now, can you tell me for one subject how many times they did the sodium test? 4 times. One was at minus 18th day. The second one at the study day 1. Third time is the 14th day of the study. 46th day of the study. Now tell me, out of these 4, which one is the baseline value? Which observation is BLFL is equal to Y?
One.
This one, because this is the most recent value on or before the treatment. Now for this observation, can you see BLFL is equal to Y? When we have a BLFL is equal to Y, whatever the AVAL value that we have, that will become the base value. Very, very important definition. Now, how you derive base? What is the base value? Now, how you are going to explain that one? For whichever observation, BLFL is equal to Y, that observation AVAL value will become base value.
Base.
Now, when we have a BLFL is equal to Y here, what is the AVAL value I have? 140.
140.
Okay. Now, this 140, I'm going to populate it as a base variable. Now, what is the formula for the change now? Change is equal to AVAL minus
AVAL minus
base.
Minus base.
140 minus 140 is equal to 0. 145 minus 140 is equal to 5. 149 minus 140 is equal to 9.
9.
This is called change, and this is how we generate the change. When once we get change in the percentage in change, baseline to change, ratio to change, we can do a lot of analysis variables later. You are going to have very important, very regularly, you are going to get a question from the base and change. How you derived the base? What is the definition? Tell me the algorithm for the base. These are the questions that you will have. So for whichever observation we have an ABLFL is equal to Y, that observation's eval value will become base value. And then once you populate the base, I will tell you later programmatically by using a return statement and first dot test series, last dot test series, we are going to do this one. And then we are going to create change is equal to eval minus base. Understand this one? Now, these are the 6 important steps that we have while you're converting SGDM findings dataset into ADaM's BDS dataset. Understand this one? Now, tell me one more time, what is the first step that we have? The first step that we have is we should create a precursor dataset. What is a precursor dataset? Findings main dataset plus it's a supplementary dataset. How to merge that supplementary back into again the main dataset? First, we need to transfer the supplementary dataset, and then we should merge with the main dataset so that we can create a source dataset. Okay, and here I have a programming snippet, and this is how we are going to do. Very, very important interview question. They'll ask you the syntax, how we are going to retranspose the supplementary, which variables are going to keep in which statements. Okay. And then second step, convert all the date characters into numerical. So we are going to have date characters and we should convert into numerical. But while doing that one, it is not going to be straightforward. Sometimes we are going to have missing values. How to handle those missing values. This is the method that we follow. And then we are going to go with the third, which is in a DY. ADY analysis, which is nothing but LBDY. If you have already created an SCDM, no need to worry. But if you didn't do that one, now we should create that one here. And then fourth step, important key variables. What are the important key variables? PARAM, PARAM CD, AVAL. Okay. And then after that, now then we have, if you want to create any new observations, we should derive the new observations. Very, very important concept. In the tomorrow's class, we'll say when we should create a new variable, when we should create a new observation, how to create a new observation. We'll see that one in tomorrow's class. And then the next step is timing windows. If you require timing windows for our study, according to the sponsors given specification, we are going to create timing windows. A specification ఎలా create చేస్తామంటే we are going to have a statistical analysis plan, SAP. Based on that, we are going to create specification. By using the specification, we create the windows. Here we have a simple example. I have 3 windows in this study: baseline window, treatment 1 window, treatment 2. For baseline, I have a day 1. For treatment 1, I'm using 45th day. For treatment 2, I'm using 135th day. And then how to derive the change? So now we are going to derive. Before the change, we should have a base. And you know how to derive the base. Whenever we have a BLFL is equal to Y, whatever the value that we have in that observation eval value, that eval value is going to become base value. Then I'm going to create a change. So these are the 6 steps that we have overall. This is how we can divide into the whole process. Clear, everybody? Now I will upload this PPT into WhatsApp. Please go through, and in tomorrow's class, we'll see when we create new variables, when we create new observations in BDS dataset. If you see that one, you'll get an overall idea. And day after tomorrow, we'll start writing the program for a BDS dataset. Okay? Clear, everyone?
Yes, sir.
Okay. Then. See you in tomorrow's class.
See you, sir. Good night.
See you. Yes, I will share.
Thank you, sir.